Hey guys, 6.5 is kind of a lengthy one. We're going to do this in chunks over a couple different days. I'm going to make lots of different videos, just so you know what to expect. So with 6.5, we're going to start by trying to simplify radical expressions. And a radical is simplified when you have taken out all of the square factors inside of the radical. That said, your final answer might still have a radical sign in the final answer. So let's jump into an example here. When I look at 1a, I'm going to take this one piece at a time. The first thing I want to recognize is the fact that this can be rewritten as the square root of 12 times the square root of c to the 6th times the square root of d cubed. And this is going to help me because, well, let me do the 12 here. What I want to do with the 12 is try to take out, like, what is the biggest square number that divides evenly into 12? And so I've got the square numbers listed here to the side, and the biggest square number, that's this column over here, the biggest square number that evenly divides into 12 is 4. And so I can recognize that 12 is actually the same thing as the square root of 4 times the square root of 3. And the reason that's helpful is because I know that the square root of 4 is just a boring 2. Now the square root of 3, that's a decimal. I'm just going to leave that as the square root of 3. Anything that's a decimal is going to stay underneath the radical sign. So then, using my rules that I know about the exponents under radical sign, I'm just going to take this 6 divided by the index, which in this case would be 2. And 6 divided by 2, that's even. That would just be c cubed. C cubed. Now the d is where things are going to be a little more interesting because 3 divided by 2 is not a nice happy number. And I want happy numbers only. So what I'm going to do is recognize that I can kind of split this up to be d squared times d to the first. If I add exponents, that would give me d cubed. And what that has done is allowed me to have the square root of d squared, which cancels nicely. So that would just be a nice happy d on the outside with another square root of d to the first power there. So my final answer then is going to be everything that's on the outside written together and everything that's on the inside written together. Okay, I want to go ahead and do another example because I know these are weird. So this one over here, you don't have to necessarily rewrite with all the different radical signs like I did in this step over here. I'm just telling you that sometimes that can help be a nice visual. So if you want, maybe kind of highlight one thing at a time. So I start with the 27. The cube root, watch out, it's a cube this time, of 27. I want to take all the factors of cube out, but it turns out this time that's just a nice happy 3. The cube root of 27 is 3. Okay, so next up I'll work on the y to the 12th. And 12 evenly divides by 3, so that just gets to be a y to the 4th. Z to the 7th, 7 does not evenly divide by 3. So I'm going to split that up to the biggest number, smaller than 7, that is evenly divisible by 3, which would be z to the 6th. And so that leaves me with 1z left over. So this cube root of z to the 6th becomes z squared. 6 divided by 3 is 2. And that means my cube root of z to the first, or just regular z, is what's left over, making that my final answer. Oops, didn't mean to delete that. I wanted to something like that. Struggling over here. All right, that's going to be video 1.